In the intricate architecture of both a computer and the human mind, memory plays a foundational role, operating through different systems that mirror each other in function and persistence. We can think of the computer as a digital brain, with its components mapping directly to how humans process and store information. The computer's ROM, read-only memory, is the machine's very soul, the fundamental, unchangeable instructions required to wake it up and tell it how to be a computer. This is perfectly analogous to the instincts and innate knowledge we are born with, the hardwired biological imperatives like knowing how to breathe, blink, or sense danger. This foundational programming is written at the factory, or in our DNA, and remains largely permanent throughout our lives, forming the bedrock of our existence that we never consciously edit. When the computer is running, it uses RAM, random access memory, as its temporary workspace. This is where active thought happens. When you open a program, the computer quickly jots down the necessary data in RAM so the processor can access it immediately. This memory is volatile. Close the program or shut down the machine, and that data vanishes instantly. This perfectly mirrors our working memory or short-term memory. Think about the moment you are given a new phone number to dial. You hold those 7 digits in your conscious mind just long enough to input them. That information is currently in your RAM. Once the call connects, you forget the number unless you make a conscious effort to repeat it and move it to a more permanent location. Our working memory is our cognitive scratchpad, dealing with the present task, quickly clear to make room for the next thought. Finally, while outside the scope of the immediate ROM/RAM comparison, the computer's hard drive provides the long-term, persistent storage that maps to our long-term memory. This is where everything you've ever learned, every experience you've had, and ever